a question that sounds simple but gets deep fast. How does Bitcoin, a network of thousands of computers spread across the entire planet with no central authority, agree on a single version of the truth? No voting, no leader, no committee, just math and incentives. This is Nakamoto Consensus, and it's one of the most elegant inventions in computer science. For Bitcoin, the double spend problem was the reason digital money always needed a central authority. If I can copy a digital file, what stops me from copying my digital money and spending it twice? The traditional answer was a bank, a trusted third party that keeps the ledger and says no to double spends. But Bitcoin solved this differently. Instead of trusting a bank, you trust the chain with the most accumulated work. How it works. Bitcoin transactions are grouped into blocks. Each block contains a reference to the previous block, a cryptographic hash. This creates a chain. Change one block, and every block after it becomes invalid. The chain is tamper-evident by design. But here's where it gets interesting. What happens when two miners find a valid block at roughly the same time? Actually happens. Two miners solve the proof-of-work puzzle almost simultaneously. They each broadcast their block to the network. Some nodes see block A first, others see block B first. For a brief moment, the network is split. This is called an accidental fork. Bitcoin's solution is elegant. Keep building. Whichever side of the fork gets the next block becomes the longest chain, and the other side is orphaned. This is the core of Nakamoto Consensus. The valid chain isn't the one that arrived first. It's the one with the most accumulated proof of work. Miners always build on the longest valid chain they know about. When a longer chain appears, nodes reorganize. Transactions in the orphaned blocks that weren't confirmed in the winning chain go back to the mempool. This process is called a chain reorganization, or reorg. Reorgs happen more often than you might think. One-block reorgs occur roughly once every few weeks. Two-block reorgs are rare but not unheard of. Deeper reorgs are extremely unlikely because an attacker would need to outpace the entire rest of the network. This is why the standard advice is to wait for 6 confirmations. After 6 blocks, the probability of a reorg is astronomically low. What if someone controls more than half the network's hash rate? In theory, they could build a longer chain in secret and then release it, overriding the public chain. This is the 51% attack. It's expensive. You'd need billions of dollars in mining hardware and electricity. And even if you succeed, all you can do is double spend your own transactions or censor others. You can't steal coins, create bitcoins out of thin air, or change the rules of the network. Part most people miss. Miners don't actually control Bitcoin's rules. Full nodes do. A full node validates every transaction and every block against the consensus rules. If a miner produces a block that breaks the rules, maybe it creates extra bitcoins or spends coins that don't exist, full nodes simply reject it. The block never enters the chain. Miners provide security, but nodes enforce the rules. An important distinction between consensus rules and policy. Consensus rules are non-negotiable. Everyone must agree on them, or the network splits. This includes things like the 21 million cap, the block subsidy schedule, and the proof-of-work algorithm. Policy is softer. It's how individual nodes choose to handle transactions. Some nodes might relay transactions with very low fees. Others might not. This flexibility is a feature, not a bug. This consensus mechanism is the reason it survived for over 17 years without a single successful attack on the protocol layer. No committee, no leader, no downtime. Just math. If you want more deep dives into Bitcoin's technical foundations, subscribe and zap this video. Lightning address is in the description. Stack sats, stay curious.